If V2 less than V1, then compression work done reversible is positive value, then work done on the system. Students completed? Okay. Students, remaining students completed. Yes. We are calculating work done in a isothermal process. Isothermal process, delta T equal to 0. So the delta U equal to 0, internal energy 0. Then first law of thermodynamics, delta U equal to Q plus W. So that you can write Q equal to minus W or W equal to minus Q. We are doing work done in isothermal reversible process. Whether it is a reversible process or irreversible process, whatever it may be, it is isothermal process. So W reversible, W in case negative value, Q is a positive value. Okay, W is positive. Who is that? Who is that? W is a negative value, students. You will get a positive Q. If you get a W value positive, you will get negative Q. So in given question, what is the heat? Isothermal reversible process. Then find work done. Work done, if you get positive value, heat is negative value. Okay, if you get work done is negative value, heat is positive value. Are you getting my point? Equation is same equation, but sign is different. Understood? Students getting or not? So please note down this very important point. Same equation, but you can use for two different factors. One is work done. Students, we calculated work done in reversible process. This is the equation. But we know that isothermal process Q equal to minus W, W equal to minus Q. So if you get question like what is the heat in isothermal reversible expansion or compression of the ideal gas, then you can find work done. Same formula you can use. If you get positive value, heat is a negative value. Suppose if you get work done is a minus 1313 joules, then you can Q value is plus 1313 joules. Are you getting my point? If you get work done is a positive value, heat is a negative value. Got it? Students, it's very difficult to teach, like if you are not giving any reply for me it is very difficult to teach. Whether you are getting or not, how can I understand? Please try to give reply for my questions. Please respond. I repeat again, this is the equation, students. Do you understand how we got the equation? The equation is isothermal reversible process. In that, what is the work done? We calculated, this is the equation. Now I am saying same equation you can use for Q. What is Q? Heat absorbed by the system or heat released by system. Why Q equal to minus W? Reason, we are doing isothermal process, so that delta T equal to 0, internal energy is 0. First law of thermodynamics converted into Q equal to minus W or W equal to minus Q. So this equation we can use for Q also. So here W is reversible negative. You can keep here negative. W reversible is a positive minus Q. So this is the equation for minus Q. Got it? Yes. Okay. So one more point, students. One more point. We already studied Boyle's law. Boyle's law means temperature is constant. And we know that P1 V1 equal to P2 V2. Then we can write V2 by V1 equal to P1 by P2. So if they given volumes, you can use this equation. In case if they given pressure, P1 initial pressure, P2 final pressure, then work done reversible is minus 2.303 nRT log P1 by P2 base 10. This is another important equation. So if you get questions on expansion of gas, volume, if they given, you can use first equation. In case if they given pressures, you can use second equation, where P1 is initial pressure, P2 is final pressure. Okay, students. Right. Next, log 1 value 0. Log 1 value 0. Log 10 value 1. Log 2 value 0.3020. Log 3 value 0.4771. Log 4 value 0.6040. Log 5 value 0.699. Okay, students, you need to remember at least these values. And you can calculate logarithm values by using logarithm table. Even in JEE mains and JEE advanced exams, they will give logarithm books in examination. They, because they won't allow calculators and remaining things. So you have to know how to find out logarithm values and anti-logarithm values. So they will provide logarithm book. In that logarithms, anti-logarithms are present. So you can check the logarithm values. Okay, because work done, all these values are related to, the formulas are related to logarithms. So please note down. At least you have to remember these values. Log A into B, log A plus log B, log A by B, log A minus log B. Completed. Okay. One question related to this formula: when 1 mole of helium gas or 1 mole of an ideal gas compressed isothermally and reversibly to 1/5 of its original volume at 300 Kelvin. Find work done in this process. Students, work done you can find in joules. Joule. Likit Naidu, wrong answer. Shashank, you're very close to the answer. Ropak, yes. Satya Vinay, okay, wrong answer. Shashank, almost very close to the answer. Yes, Ropak, correct answer, Nana. Ropak, correct answer. So, equation for this work done reversible is minus 2.303 nRT log V2 by V1 base 10 minus 2.303 n value 1 mole, R value 8.314 joules, T value 300 Kelvin, log V2 1 by fifth, I mean 1 by 5 V by initial volume V. V get cancelled. Now minus 2.303, 8.314 into 300 log 1 by 5 value. So log 1 by 5 means log 5 inverse. Log a to the power of x. Log a to the power of x. X log a. So minus 1 minus plus. So now log 5. Log 5 value 0.699. If you substitute that and you will get answer 4014 joules. 4014 joules. Students got it? So do you want one more question? Okay, right. One mole of argon gas expanded from 50 liters to 500 liters at 27 degrees Celsius. Find out work done. Work done in reversible process. Kartikeya, okay. Shashank, okay. Neha, okay. Right, students, same formula. Work done reversible process is minus 2.303 nRT log V2 by V1 minus 2.303, N value 1, R value 8.314, temperature is 300 Kelvin, should be Kelvin, and log 500 by 50, 0, 0, 5 times, 10 times cancel, log 10 value 1. Students, if you multiply this, then what is the answer? Minus 2.303, 8.314, 300. What is the exact value? Since log 10 value 1. Some students given 5063. Yes, okay. Minus 5744 joules are minus 5.744 kilojoules. Yes, students. Same question. Find out heat. Find out heat. Question. Find out heat. Then answer is plus. Very easy, students. ఇదే క్వశ్చన్ లో మీకు హీట్ అని ఇచ్చాడు అనుకోండి, ఫైండ్ అవుట్ హీట్ ఇన్ ద రివర్సిబుల్ ప్రాసెస్ అంటే మీరు ఆన్సర్ వచ్చిన ఆన్సర్కి ఏం చేయాలి? ప్లస్, అంతే. ఓకే, డన్. నెక్స్ట్ case 2 is work done in isothermal irreversible process, irreversible free expansion or into vacuum. Right, students, now question is, what is the work done in isothermal irreversible free expansion? Work done in irreversible free expansion. Now I need one clarity, students. We are doing one experiment in a cylinder which contains frictionless piston. They said free expansion. What is free expansion? Are into vacuum. Free expansion means opposing force is 0. P external equal to 0. What is free expansion? No opposing force. In vacuum, no pressure is there. So now tell me, work done in irreversible process, free expansion. What is the answer? Yes, Vikrant, you got it. Remaining students, what is the answer? My question is, what is the work done in free expansion? Work done formula same everywhere, P external into dV. P external here 0, so work done here 0. Very, very simple students. అంటే vacuum లో ఎక్స్పాండ్ అయినా ఆపోజిట్ ప్రెషర్ లేకపోయినా వర్క్ డన్ ఈజ్ డెఫినెట్లీ 0. And first law of thermodynamic, isothermal process, delta U0, delta T0, isothermal process. Now first law of thermodynamics, delta U equal to Q plus W. It is 0, W also 0, so Q also 0. Students, in vacuum or free expansion, everything is 0. Delta U 0, delta T 0, work done 0, Q equal to 0. Very, very important. In actually, many times they have given this question in JEE mains and JEE advanced. It's a in thermodynamics, the questions are little bit lengthy compared to remaining questions. You can see free expansion or into vacuum in the question. Without any doubt, you can keep answer 0. అర్థమవుతుందా మీకు? క్వశ్చన్ ఎంత లెంతీగా ఉన్నా సరే అక్కడ ఫ్రీ ఎక్స్పాన్షన్ అని కనిపించగానే అక్కడ ఆన్సర్ లో 0 ఉంటుంది. యూ కెన్ కీప్ ఆన్సర్ 0. సో ఇక్కడ irreversible process, the external pressure is 0. That's why here it is called free expansion or into vacuum. Students completed. Okay, next. Next, work done in isothermal reversible process. What is the difference between this case and previous case? Previous case, we can see free expansion, but it is a reversible process, no doubt, but there is external pressure. Let us consider same kind of process. Now there is a external pressure. Now what is the work done? Work done equal, work done you must represent here irreversible, equal to minus P external into delta V. What is delta V? Final volume minus initial volume. This volume related to gas inside the cylinder, let us assume it is an ideal gas. Now, PV equal to nRT, V equal to nRT by P. Okay, students. Now, this equation we can write minus P external equal to into V2, volume of this ideal gas, I can write as nRT by P2, because at V2 pressure is P2, temperature number of moles R is same, minus nRT by P1. nRT is constant, same, so common is minus nRT. P external by P2 minus P external by P1. Students, now tell me, initial pressure is P1. When it is expanded, the final point, it is an irreversible process. The final state of pressure is P2. This P2 must be equal to P external pressure. Am I correct? Why? It is an irreversible process. It will stop somewhere when external pressure equal to internal pressure. So definitely P2 must be equal to P external. Got it? P external must be equal to P2. Understood, students? Say yes or no. Okay, right. Next to minus nRT P2 by P2 minus P2 by P1. And you can cancel P2, P2. Then final equation is minus nRT into 1 minus P2 by P1. Students, you must use this equation work done in irreversible process. So don't use this equation for reversible, and for reversible equation don't use this equation. They will mention in that question whether it is reversible process or irreversible process. So by studying the question clearly, if it is a pre-expansion, 0. If it is a reversible process, that equation. It is a irreversible process, this equation. Minus nRT into 1 minus P2 by P1. Students, completed. ఇవి చాలా ఇంపార్టెంట్ ఫార్ములా స్టూడెంట్స్. అంటే మనకు వచ్చే ఎగ్జామ్ లో జేఈ మెయిన్స్ అండ్ జేఈ అడ్వాన్స్ లో మాక్సిమం క్వశ్చన్స్ మనకి వర్క్ డన్ మీద అడుగుతారు క్వశ్చన్స్, పర్టికులర్ గా ఐసోథర్మల్ ప్రాసెస్ లో. సో డోంట్ కన్ఫ్యూజ్. ఈ ఈక్వేషన్స్ అన్ని మీరు చాలా ఐ మీన్ గుర్తుపెట్టుకోవాలి. డెఫినెట్లీ వస్తాయి క్వశ్చన్స్ అన్ని కూడా. వెరీ ఈజీ. ఓకే, డూ యూ అండర్స్టాండ్ ది డెరివేషన్ పార్ట్? ఓకే, రైట్. Now my question is, and very important question also, you have done some work in reversible process and also in irreversible process. In which process you have done more work? That is a very important concept. So students, work done reversible process equation minus nRT natural logarithm ln P1 by P2. Okay, it is work done reversible. Work done irreversible equal to minus nRT into 1 minus P2 by P1. Fine. W plus W means work done on system. Plus W means work done on system. For our simplification, I am writing here minus W, minus W. Then here positive. Minus W means work done by the system in the reversible process, isothermal. Work done by the system in irreversible process, isothermal process. Which one is greater? Okay, right. Can I write this equation as, students, here base E? That's why I'm not writing 2.303. It is a base E. Can I write this equation as nRT into 1 minus 1 1 minus 1 minus P1 by P2? Can I write this equation like this? 1 1 cancel, remaining will be P1 by P2. Can I write? Yes, we can write. Sorry. This will be logarithms, right? Ln into 1 minus 1 minus P1 by P2. Yes, we can write, because 1 1 cancel, minus minus P1 by P2. We studied, students, expansion of terms log 1 minus x base c. Expansion is minus x square by 2 minus x cube by 3 minus x for 4, so on. It is expansion of logarithms. Okay, generally our pressures are change in pressure, the P1 by P2, the value will be very less. So let us assume, I am assuming, I hypothetically assume that x is very small, then these terms are very small. So let us consider these are negligible terms. Now I can consider only minus x. So log base e 1 minus P1 by P2. Can I write? It is 1 minus x. 1 minus x. So can I write it is minus of 1 minus P1 by P2? Because this value is x. Can I write like this? Right, Chaleda? ఓకే, నేను మళ్ళీ చెప్తా చూడండి. Student, this is the equation. You got it right. Next, ln 1 minus x base c expansion is minus x square by 2 minus x cube by 3, so on. Here, if I write same here, 1 minus into 1 minus p1 by p2, I'm taking this 1 minus p1 by p2 is x. Then it is x minus x square by 2. I said this value is very low. X value is already very low, then x square by 2 also very low. So I'm taking all these terms are negligible except minus x. So I can write this equation as minus of 1 into 1 minus p1 by p2. Got it now? Okay. So in place of this, I'm writing this term, then nRT into minus of this, can I write P1 by P2 minus 1? P1 by P2 minus 1. Students, now do minus work done reversible, ante work done by the system minus work done by the system in irreversible. What is the work done in a reversible process? nRT into P1 by P2 minus 1 minus of work done by the system in irreversible process. This is the value nRT into 1 minus P2 by P1. nRT is common. nRT P1 by P2 minus 1 minus 1 minus into 1 minus 1 minus into minus plus P2 by P1. Students, this value positive or negative, tell me. This value nRT into P1 by P2 minus plus P1 P2 by 1, is it positive value or negative value? Okay, students, note down up to this. Note down up to this. I have no space here. Please note down this immediately. Make it fast. Completed. Now the expression is nRT LCM is P1 P2. LCM is P1 P2 by, so we can say P1 square minus P1 P2 minus P1 P2 plus P2 square. This is the equation. P1 square minus 2P1 P2 plus P2 square. So we can write nRT P1 minus P2 whole square by P1 P2. Students, we are doing square. So if it is a positive value, positive, negative value, so negative value also positive. Finally, this term is positive value. So I want to do no need of derivation for exam students. I want to convey this value is positive. So minus work done reversible, I mean work done by the system minus of work done in a reversible process is a positive value. So positive value means greater than 0. So greater than 0 means you can write work done in a reversible process is greater than work done by the system in irreversible process. అంటే ఫైనల్ కాన్సెప్ట్ ఏంటంటే if you అంటే system, if system does work reversibly, that work done is major compared to if system does work done irreversibly. అంటే సిస్టమ్ తన అంతట తాను వర్క్ చేస్తే రివర్సిబుల్ ప్రాసెస్ లో ఆ వర్క్ చాలా ఎక్కువ, వేరాజ్ ఇన్ ఇర్రివర్సిబుల్ ప్రాసెస్. అర్థమవుతుందన్న? అందుకే మనం చెప్పాం వర్క్ డన్ ఇన్ రివర్సిబుల్ ప్రాసెస్ ఇట్ ఇస్ ఐడియల్ ప్రాసెస్, అంటే ఎక్కువ వర్క్ చేయాల్సి వస్తుంది అక్కడ. సో ఈ కాన్సెప్ట్ చాలా చాలా ఇంపార్టెంట్. ఇక్కడ మైనస్ అంటే వర్క్ డన్ బై ద సిస్టమ్, అదే మీరు మల్టిప్లై విత్ మైనస్ దెన్ ఇట్ ఈస్ విల్ బి పాజిటివ్ రివర్సిబుల్, ద సైన్ విల్ బి డిఫరెంట్ నౌ. అదే వర్క్ డన్ ఆన్ ద సిస్టమ్ చేస్తే work done on the system irreversible process is greater than and work done on the system in irreversible process. అర్థమైందా మీ కాన్సెప్ట్ స్టూడెంట్స్? ఇప్పుడు ఇక్కడ వర్క్ డన్ బై ది సిస్టమ్, వర్క్ డన్ ఆన్ ద సిస్టమ్ రెండు కంప్లీట్ గా అర్థం కావాలి. వర్క్ డన్ బై ద సిస్టమ్ ఇన్ రివర్సిబుల్ ప్రాసెస్ ఈస్ గ్రేటర్ దాన్ ఇర్రివర్సిబుల్. వర్క్ డన్ ఆన్ ద సిస్టమ్ ఇన్ ఇర్రివర్సిబుల్ ప్రాసెస్ ఈస్ గ్రేటర్ దాన్ రివర్సిబుల్ ప్రాసెస్. అది నాన్న, అది రాసుకోండి అక్కడ. Students completed? Okay. Students, please read these concepts again because these are very, very important. Very, very important. Definitely you can see in all kind of exams. Thank you.